Okay, just to continue our discussion from the last video, I have a new production function up here, and I just want to make sure that you kind of understand what's going on here. So you'll notice I have the labor and the output. I don't have the capital up there because the capital, again, is constant, and so it makes no sense to have just a column with the same number, right? So you can interpolate that given this variable labor and some fixed capital, this is the amount of output. Okay, so if you were to see this on an exam, the column that's missing is marginal product. So go ahead and write marginal product there, and let's see what we have here. So the first thing is I can calculate some of the marginal product, right? Because the marginal product of that first worker is what? 3 minus 0, 3, and the marginal product of the second worker is 5, right? Because 8 minus 3 is 5, okay? If I asked you what the average product was when, let's say, 2 workers are hired, what's average product? Well, average product is just the output, in this case 8, divided by the number of workers. So 8 divided by 2 is 4. So on average, those each worker is responsible for 4. But notice how the average product is different than the marginal product. We know that the first worker can bang out 3. Let's say this is a lawn mowing business, okay? So my first worker can mow 3 lawns in a day, but my second worker can mow 5 lawns in a day, right? But on average, they mow 4 lawns a day, okay? Now, if I say that the marginal product of the third worker is 7, okay, so if I give you that, if I say the marginal product of the third worker is 7, then what's the total output, right? It's simply that third worker can mow 7 lawns, so 7 plus 18 is 15, so a total of 15 lawns can then be mowed, okay? Yeah. Now, let's go back to diminishing marginal returns. When does diminishing marginal returns set in? Well, let's finish it out, right? That's 6, right? 21 minus 15 is 6. 24 minus 23. And so what do? We look for when the number gets smaller. So 5 is bigger, 7 is bigger, 6 is smaller. So we would say that diminishing marginal returns sets in with the 1, 2, 3, 4th worker. Okay? So that's the way that the production function works, and that's the way that marginal product works. Okay? Now, let's do this. Let's talk about cost of production. So recall in the short run, cost of production. What I'm going to do is I'm going to put kind of a wall of numbers up here, okay? So the thing to know, so if we go revenue minus cost equals profit, we can actually break this down a little bit more, right? Because we know revenue is price times quantity, but cost, what is cost comprised of? Well, it turns out that total cost is total fixed cost, right? Because in the short run, remember we talked about there's a fixed and a variable. Total fixed cost plus total variable cost, okay? And that's what I want to explore right now. So, I'm going to put a bunch of numbers up here, and our goal is simply to use those numbers to get to a picture, all right? And we'll put quantity here, and we'll say 0, 1, 2, 3, 4, 5. I'll just keep it at 5. How's that? Now, total cost. If I say my total cost is 100, right? And I know that my total cost is a combination of my total fixed cost and total variable cost. And if I haven't made any pizzas, let's go back to pizzeria. You know what? Let's talk about snow cones. All right. So we own a snow cone firm, right? I haven't made any snow cones. Okay. So let's talk. Let's reduce this down and make it simple. A fixed cost is a cost that doesn't change based upon the quantity of output. So the best example of a fixed cost is rent, right? You got to pay your rent no matter how many snow cones you make. Versus variable cost, which is a cost that, again, varies upon the output, the quantity of your output, okay? So in this case, we'll just reduce it down to syrup, okay? So if I haven't made any snow cones, how much syrup am I going to use? 0. But do I still have to pay rent? Yeah, I do. And let's just say my rent is 100. Now, I know that because, look, if this plus this equals this, and this is 0, fixed costs have to be what? 100. And once you know 2 of those, you can always figure out the third. So in other words, if I said that my variable cost for the first snow cone was 60, right? Well, I know my fixed cost is 100, so my total cost is going to be 160. I guess snow cones don't really make sense, because $160 snow cone isn't going to work, so we'll have to pick something else out. But you see how this goes, right? So for 2, if I say 210 is the total cost, well, I know this fixed cost, right? It doesn't change, it's fixed. So I know that my variable cost is going to be 200 minus 100, 110. Okay? So you should be able to go through, and again, this isn't going to change. If my variable cost for the third unit is 160, then this is going to be 260, right? Because you can do math. If this is 320, then my variable cost is going to be 210, or I'm sorry, 220. And then for 5, if this is 310, then my total is 410. Okay, all right, that's a lot of numbers, right? And again, it's pretty straightforward. So if you're given 2 of any of those, you should be able to figure out the third one. Now what we want to do, though, is we want to look at the same thing, average total cost, but make it average total cost instead of just total cost. And average total cost, again, is going to be this average fixed cost plus average variable cost. Okay? I know it's a lot of numbers, but hang in there. Okay? Now, with 0 quantity, so all you're going to do for the average is you're going to take, like in the case of total cost, you're going to take total cost and then divide it by the quantity. Well, 0, anything divided by 0 is going to be 0, right? So that's pretty straightforward. But for the first unit, though, total cost 160 divided by 1 is going to be 160. 210 divided by 2, average total cost is going to be 105. Makes sense? And then we do the same thing for the fixed cost and the variable cost. So fixed cost, 100 divided by 1 is going to be 100. 100 divided by 2 is going to be 50. Right? You see how that goes. And then variable cost, the same thing. So 60 divided by 1 is 60. And then you can see 110 divided by 2 is 55. Okay? And then you can also see same thing here, right? So 60 plus 100 is 160, 55 plus 50. So your average total cost is just the sum of the average fixed cost and the average variable cost. So if I gave you, again, 2 of these, So if I gave you, I'm going to round up here. This is actually 86 point something something. But if I said that's 87, and your fixed cost, average fixed cost is 33, then, you know, what is your average variable cost going to be, right? 54? See how that works? If I said that, you know, your average variable cost is 55, and your average fixed cost is 25, then what's that come out to? 80, right? So you can kind of see how that goes. All right, and then I'll just put up the rest of the numbers. 82 is total cost, 62 variable, and then 20. Okay, it's a lot of numbers. But what we want to do, and where we're going with this, is I'm going to erase this so that I can draw over here. But we want to graph that because we want to see what those short-run costs look like in graph form. And this is pretty imprecise, but here you go. We'll start with the easy one, average fixed cost. It kind of makes sense that that's just our average fixed costs are going to go down, right? Because it's a fixed cost, and as you divide it by more and more, you know, pizzas or snow cones or whatever the output we're talking about is, then that number is going to get smaller. So if we graph it out, average fixed cost looks something like that. It starts out kind of, you know, big, and then it gets smaller. Okay. Average variable cost, you can see, gets big, then gets small, and then starts getting bigger again, right? So it kind of looks like that, average variable cost, okay? And then, as you can see from the equation, your average total cost is your average fixed and your average variable added together. And we can literally do this. So if I say for this increment right here, this is my fixed cost, I can just add it in, right? Add it in right there. For this increment, that's my fixed cost. So I'm just going to add it in right there. See how that works? You know, for this increment, there's my fixed cost. I'm just going to add it in right there. And so, in fact, average total cost looks something like that. And what that allows us to do then is we can actually get rid of the average fixed cost because we don't need it, because we know that this is the average fixed cost right in here, because you saw me add it on top. So the space between these two curves is your average fixed cost. This is your average total cost, average variable cost. And then we've talked about marginal cost, and I'm going to kind of not spend too much time talking about it because we've already defined it, right? And I'm just going to suffice it to say, recall that marginal cost, right, is the cost of each additional increment or unit of something. And what's unique about marginal cost is that even though it doesn't really look this way because I'm not drawing it super accurately, it always intersects these two curves at their lowest point, okay? And this is where we're trying to get to. This is where I was trying to get to, okay? It's important to, you know, kind of understand all those numbers, and I kind of went through it quickly, but this cost structure is what short-run cost looks like. And again, it's short-run because it has a variable and a fixed component that added together add to a total component. But this diagram becomes very, very important in the next chapter as we start talking about different market constructs and different profit conditions that a firm may find itself in, okay? So I'll leave it at that now and get back to you here shortly.